All right, today we're looking at notes 11-5, complex fractions. So this is a pretty fun lesson, one of my favorites. All right, so I want to remind you, if you've got something like 3/5 over 4/5, remember in math it's not legal to have a fraction over a fraction. So this here means you're dividing 3/5 by 4/5, and also remember something we've talked about recently. If you're dividing fractions, you flip the second and multiply. So this essentially means 3/5 times, we flip this second, 5/4. And hopefully, I like that you would use the method of canceling out the diagonals. You can, which would leave you with 3/4. Okay, if you think about it, those two cancel, it'd leave you with 3 over 4. But if you need to, you can multiply across the top, which would be 15 over 20, which, what do you know? It simplifies to 3/4. Okay, so let's apply that knowledge to this. Okay, I've got a fraction over a fraction. Again, it's not legal in math. So what I need to do is I need to flip the second and multiply. But unfortunately, before I can even do that, I need to combine what's on top here and combine what's on bottom here. So again, unfortunately, all right, I've got a fraction here and a non-fraction here. So in order to add fractions, I have to have a common denominator. So essentially, I need this 3 to have a denominator of x, like this. So that means I need to multiply this 3, which is really 3 over 1, by x over x. So I'm going to rewrite this as 1 over x plus 3x over x, and then I'm going to do the same thing on bottom here. Okay, to be able to add these, I need to have common denominators, so I'm going to make this 4 over 1 and multiply by x and x. So that would be 5 over x plus 4x over x. Now I can rewrite nicely. By combining, I have common denominators, so this would be 3x plus 1. Unfortunately, I can't combine those. Over x, all over, this would be 4x plus 5 over x. And now I've got these nice fraction over fraction that I can go ahead and flip the second and multiply. So I have 3x plus 1 over x, and I flip this second, times x over 4x plus 5. So again, I taught you before, I showed you before, you can cancel out the diagonals, so you can cancel out these diagonals if you're good at that, or if it confuses you, do it like we've been doing it before. So when I multiply something like this, I multiply across the top and across the bottom, and I bring monomials to the front. So this would be rewritten x, 3x plus 1, over x, 4x plus 5. And obviously in this scenario as well, I could have done it here, but I can also do it here. These x's cancel, and I'm left with 3x plus 1 over 4x plus 5. And now we just need to list our restrictions. You know what? We're not even going to worry about those for this problem. We'll get to that later, okay? So for now, don't worry about restrictions. Let's just worry about doing all this math. Okay, on number 2, nothing needs to be done there, but on bottom, you have to combine these two. So you need to put this 1 over 1, which is what it really is, have the same denominator as this, so multiply both top and bottom by 2y. Okay, so on top it stays the same, 3 over y over 2y over 2y minus 1 over 2y, which equals 3 over y over 2y minus 1 is 2y minus 1 over 2y. Now that it's combined fraction on top, combined fraction on bottom, I can keep the first one the same, flip the second and multiply. So 2y over 2y minus 1. So again, okay, this is a binomial. You probably want to put all your binomials in parentheses and then multiply across the top and across the bottom. So 3 times 2y is 6y over this. I'm going to keep the monomial towards the front, put the binomial towards the back, and then look at what I have. So here, this y and this y cancel, and nothing else can be done. So I have 6 over 2y minus 1. I know you want to simplify that, but you can't unless you share the love, and you can't with that, so you're done there. Okay, so I'm going to go ahead and box this up, and I'm actually going to go back and box this up because I was done. I was waiting to do the restrictions, and I changed my mind. All right, on top, that is already combined fraction. On bottom, this is a real fun one. Okay, we've got to combine this. Okay, so here I've got xy squared, here I've got x squared y. So the common denominator to get would be to have x squared y squared. So I need to multiply this top and this bottom by x, and I need to multiply this top and this bottom by y. Okay, so the top stays the same, 2 over x squared over, okay, 4x over x squared y squared plus 6y over x squared y squared, okay, equals 2 over x squared over, can't combine those, one's an x, one's a y, so unfortunately got to keep them separated, x squared y squared, not sure if any of you caught that. Now here, now I can go ahead and flip the second and multiply. 2 over x squared times, flip this second, x squared y squared over 4x plus 6y. So this is a binomial. I'm going to put it in parentheses, and then I'm going to multiply across the top. So 2x squared y squared over x squared 4x plus 6y. Okay, and then here what happens is the x squareds nicely cancel. Nothing else cancels, so I've got 2y squared over 4x plus 6y. You know what you can do on bottom, actually, you can factor out a GCF of 2. So we would have 2y squared over 2, 2x plus 3y. And then the reason that's helpful is because that happens. So you get y squared over 2x plus 3y. And then you are actually completely finished. Nothing else can be done. All right, one more problem. So, last problem, I promise. Here you've got 2 over x plus 2 minus 7. So what needs to happen is to combine these, we have to multiply both top and bottom, which that's over 1, by x plus 2. So top and bottom, x plus 2. So we get here 2x plus over x plus 2 minus 7x plus 14 over x plus 2 all over. Okay, here, same thing. We need to combine both of these, so both top and bottom, that's like over 1, needs to be multiplied by x plus 2, top and bottom. So when I distribute that, I get negative 3x minus 6 over x plus 2 plus 4 over x plus 2. So when I combine here, be very careful. Okay, so I've got negative 7x minus 12 over x plus 2 all over, okay, here we've got negative 3x minus 2 over x plus 2. Okay, then now I'm ready to keep the top the same. Just rewriting the top. Flip that second and multiply. So x plus 2 over negative 3x minus 2 now. So on this one, hopefully you can see there's no monomials whatsoever. They're all binomials. So again, if you wanted to, you could go ahead and cancel across the diagonal. If you need to go ahead and rewrite it, this and this, and then this and this, I mean, hopefully you really don't. You could just see that those two are going to cancel. One's on top, one's on bottom. That leaves you with negative 7x minus 12 over negative 3x minus 2, and look at all those negatives. So what I notice is you can take out a negative on top, which would leave you with 7x plus 12, and a negative on bottom, which would leave you with 3x plus 2, and then a negative over a negative turns positive, so let's rewrite that, and isn't that so much nicer? 7x plus 12 over 3x plus 2, and I know it's very tempting. You want to make it 6, but you can't, because remember, you can't cancel a piece of a binomial, so we're just going to leave it alone.